Hello, this is question 7 in Specimen 2018. It's a statistics question about normal distribution. It's not an easy question and you have to have a good knowledge of the symmetry and how the normal distribution works. So let me show you how you can get full marks on this question. You have a machine that fills bottles with water, and the volume of water delivered by the machine to a bottle X is normally distributed with this mean 503 and the standard deviation 1.6. We have to find first two probabilities. The first one is probability. So for A, first part is the probability of X being greater than 505. Remember, if I remind you how the normal distribution looks like, is something like that. Our mean in this case is 503. So we are talking about probability of X being greater than 505. You know that these values are not in the calculator. So we have to work out with the left side of the curve because we have probabilities of X being smaller than a certain value. So we have to write that as 1 minus probability of X. Remember, the total area is 1, so if we want to find this area, we are going to do the other way around. If we want to find this area, we are going to do 1 minus this area, and this area is in the calculator and in the tables. So probability of X being smaller than 505. If you are doing the UK exams, this question wouldn't be 5 marks, so this part wouldn't be 5 marks because you can do this straight away with the calculator. But for the international levels, you have to standardize your normal distribution always. So we are going to work with Z when Z when Z is a normal 0, 1. So Z must be smaller than 505 minus 503, which is the mean divided by the standard deviation. Remember, we have to standardize our our variable. So this is 1 minus probability of Z being smaller than, that value is just 1.25. So 1 minus, and now you can go to the calculator because I think this value is not on the table. You have the tables here. So in your formula booklet, you have the normal distribution function. 125, actually, it may be here. So 125 is this value here. So the probability is 0.8944, or you can go with to the calculator to the normal CD and use mean 0 and standard deviation 1, and you get the same value. So we say, what do we say? 8944. So this is 0.1056. So this is the probability that I'm looking for, and you get here 2 marks, one for the method, so one for standardizing the normal distribution, another mark for getting for doing the 1 minus the probability instead of just the probability, and another mark for the answer. And so that 1 mark for your final answer. These are the first 3 marks. Second part of the question, of question A, they ask us this probability here. So the probability that X is between 505 and 501. So we have, for the second part, probability that is between 501 and 505. You notice that 501, so if we clean this, let me just use the same graph. We have the mean is 503. We found before 505, and 501 is symmetrical, so I have two to the left and 2 to the right of 503, and we need to find this probability. This probability is going to be this 1 minus twice this probability. And again, because I need probabilities to the left of the graph, I'm going to do 1 minus, so the red area, the red probability, that's what I need, is 1 minus 2 times, because this is symmetrical, the probability that x is smaller than 501, or 2 times the probability of x being greater than 505, because are the same probability. So this area here is the same as this area here. And if you notice, this is the probability that we just found in the question before. So that's what they expect us to do, use that probability. So this is 1 minus probability 2 times that probability that we found, that was 0.1056. And this is 0.7888. And again, 2 marks this part, 1 for the method, so for using the symmetry of the curve, the other one for the answer. So these are the first 5 marks of this question. Then for B, and I think this is, you need to realize of this, it's not completely obvious. The probability, we need to find a W such that this probability is 0.9426. So let's go into write that. So for B, they want probability of 1006 minus W smaller than X, smaller than W is 0.9426. First instance, this doesn't look super clear, but I'm going to draw the graph again. So I'm going to use our normal distribution. This is 503. That's our mean. And we are going to standardize. We are going to standardize the X to convert it into Z, and that way it will be clear. So we have 106 minus W, and then minus the mean, and just converting it into a normal 0.1 divided by 1.6, smaller than Z now in this occasion, and W minus 503 divided by 1.6. If we calculate the 1006 minus 503, you have a probability of Z being between 503 minus W, 1.6, Z, and the same, but just with the sign reverse. So this is like, I would say, if you call this minus A, this will be A. So you know that 503 minus W will have opposite sign than W minus 503. So we are talking about a minus A here and an A here. And this probability, this area here, is the 0.9426. And we have to find that minus A or that A. Again, we don't have that in the calculator. What we have is values on the left of something. So that value here will be 1 minus 0.9426, but divided by 2, because I have 2 of those. So that value there is 0.287. So what we can do, I'm going to do in the next part, in the next page, to say that the probability of Z being smaller than minus A is going to be 0.0287. And this value here actually is this W 503 minus W divided by 1.6, and this value A is going to be W minus 503 divided by 1.6. So this is what we wrote, right? So we're going to find with inverse normal distribution in the calculator this value minus a. So if you go to the calculator to the inverse normal and you put this area here, you're going to find that minus a is minus 1.9. So that minus a is minus 1.9. And we said that this is 503 minus w divided by 1.6. So from here I just find w, and w is 506.04. Yeah, so you have to realize that this is all symmetrical. This value altogether is the same as this value, but just negative. And you won't be able to do that until you standardize your normal distribution. So when you don't know when to start these normal distribution questions, sometimes it's a good idea to standardize, yeah, to code the values, because sometimes that gives you the answer very straightforward. So you have 2 marks for this part. 1 mark, no, you have 3 marks. 1 mark is for the method, is just to change into the standard normal distribution. The other mark is for using the symmetry, and the 3rd mark is just for the answer. So these are the 3 marks. The next part of the question, so we're here. Following adjustments to the machine, the volume of the water delivered to the machine by the machine to a bottle is such as the mean is still the same, standard deviation has changed, and we don't know, it's a value q. They give us a couple of probabilities, and they ask r and q. 2 unknowns, and we are going to get 2 equations from these 2 clues. So let me write what we have. So this is C. My variable x now is a normal distribution. The 503 is the same, but my standard deviation now is q, and I don't know it. I have to find it. And we have 2 probabilities. One was probability of x being smaller than r is 0.01. Smaller than r is 0.01, and the other one is probability of x being greater than r plus 6 was 0.05. So we are going to use these 2 lines to find equations. So the first one, let me leave more space. The first one is the probability of x being smaller than r if we standardize our values. So we use z, smaller than r minus 503 divided by q, because now it's not 1.6 anymore, is going to be 0.01. At this stage you can use the calculator again with the inverse normal, or this is a very, very simple value. You can go to the tables and you can use the percentage point, yeah, because it's giving you the inverse normal, and it has very, very few values, but the 0.01 is one of them. So this is telling us that z is 2.3263. So that means this value here is, and be careful, because again, I'm going to show you, and that's a common mistake, I would warn you. Let me show you the normal distribution again. We have an area that is 0.01. So probability of x being smaller than an r is this one, is 0.01. So this value is on the left, because you know the half of the graph has 0.5, so anything smaller than 0.5 is on the left of this value. And in this case, this is 0 because I'm already standardized my normal distribution. So that means that that r is negative. So anything on the left is negative. So this, when I search on the table the 0.3263 is going to be minus. Yeah, because I'm on the left side of the graph. So this is minus 2.3263. Be careful with that. This is a common mistake. So from here, I have one equation that is going to be r minus 503 divided by q is going to be minus 2.3263. So I have one equation here. And with the other line that I have, probability of x being greater than r plus 6 is going to be 1 minus, again, when I have greater, I have to translate into smaller, probability of z being smaller than r plus 6 minus 103. I'm just making it standard, so 0.1. This is 0.05. And again, this is a value that is on the table. You can find it. Is 0.05 is 1.6449. And in this case, I don't have to change the sign because I am in the other side of the graph. So this is what did we say? 1.6449. So I have another equation here that tells me that r minus 6 minus 503 is minus 497 divided by q is 1.6449. So I have a second equation, two unknowns r and q. I solve the simultaneous equations, and just just saying that there are simultaneous equations and solve them, you get 1 mark. And when you solve them, you get that q is 1.51 and r is 499.48. So mark here. You have 1 mark. What does that? 1 mark for method here and for the actual value. So 1 mark for the method and 1 mark for finding this value in the tables. And then you get another mark again for method here for the second part, and another mark for the actual value, so to find this value here. Then you have 1 mark to write the simultaneous equations. So I didn't write them together, but it's just both simultaneous equations and saying that these simultaneous equations and solve them. Another mark for the value of q and another mark for the value of p. And I have all the marks in this part. No, there were 7. 1, 2, 3, 4, 5, 6, 7. Yeah. So this question, I think, is not an easy question, and you have to know to understand well how the normal distribution works. Yeah. So that's all. Hello, if you like the video, I have a free last-minute revision course the week before your exams. The link is in the description below. I'm working with international levels for Edexcel, but if you are an UK student, you will find this very helpful as well because the questions are identical, you just have less topics. I have other courses through the year, they are all in my website and the link is as well in the description below. I would love to help you.